Okay, good evening. I have shared the scikit-learn notebook that we were working on. Okay, so what will we do today is probably what we'll just go through whatever we have learned up until now before starting deep learning. So this will be more like a recap class. Okay, and I'll try to cover everything as much as possible. Okay. And probably it will be more sort of a question answer sort of class. Okay. Right. Let me open up the first PDF that we actually did. Give me just 1 minute. Why am I not able to see what I want to share? Okay, I see it now. Okay, my screen is visible, I believe, to everyone. Um, okay, let's try to make it full screen. Guys, when I am making it full screen, is my full screen visible or is it like partially visible? I want to know this. Okay, it's visible. It's partially visible. So this full screen is not visible. Okay, let's try to then keep it this way, but I'll try to increase this screen size. Now is it visible? Are you guys able to? Yeah, see. Okay, cool. So let's start recapping what we have read up until now. Okay. going from the first class, and I hope this class is not dead today because yesterday it was completely dead, which I don't like. Um, okay. So we learned a lot about machine learning, Python, a lot of things up until now, right? And in the first class itself, I sort of explained what is machine learning. Okay. So quickly, someone answer on the chat, what is machine learning? 10, 9, 8, 7, 6, 5, 4. Subset of AI, a branch of AI to make the machine learn, to achieve AI. It's a study of statistical algorithm software program which can task problem by experience with performance, training the machines, learns from data. What else? Machine learning is a branch of AI that enables algorithms to uncover hidden patterns within data sets, allowing them to make predictions on new similar data without explicit programming for each task. That is actually the most correct answer, Newton, which is machine learning is an AI technique, okay, that enables computer to learn from experience, and this is what we have been doing up until now, right? This is what we have been doing up until now. Um, Now, definitely it is type of machine learning. For example, in this example, when I showed, I was talking about shortest route and so on and so forth, if you remember. Okay. Um, Now, what does machine learning help us do? It basically helps us get the answers for vague questions. Okay. Yes, capability machine imitate human intelligence. It is also correct definition. Okay. There are several types of machine learning. We talked about initially it was like vision processing, translation services. We can do something like stock price prediction. We can do sentiment analysis and so on and so forth. Okay. If you followed up a scikit-learn class, you would understand that how and what kind of data we can sort of analyze. And right now you have the knowledge where like you can learn a lot. Okay. So what is AI? AI basically is human intelligence exhibited by machine. Okay. Machine learning is basically obviously subset of AI, which is 100% correct. But to expand on it, it's an approach to try and achieve AI through a system to find a pattern in a subset of data. Okay. Deep learning, we haven't covered it yet. We will start it from next class. And this is one of the technique to implement machine learning. Okay. And then we have data science, where we analyze data and do something with it. Yes, there are several definitions to it. Okay. I gave you some machines initially, some very basic machines to try to understand. Now, why do we need ML? Okay. So there are several phases because of which we reach to a conclusion that we need machine learning. One is definitely business needs. Then we needed more data. Then we needed more information. We needed better way to organize SQL. Then we needed again, this SQL also became very sort of uh, congested, and we were now producing terabytes of data. And now to make use of these terabytes of data, we are using machine learning, right? This diagram we have seen a lot, even in the scikit-learn stuff. I showed you this diagram, what you do. This is the 6-step process that we always follow. We have covered problem identification. We have covered gathering data. We have covered evaluation. We have covered feature splitting. We have covered modeling. And we have also covered experiment, at least for the scikit-learn. Okay. What is the hardest part? Hardest part is definitely data collection. Unless we have data, we can't work on anything, right? To make any sort of prediction, to make any sort of judgments, we definitely need a data. If we don't even have a data, what can we do with it? We can't do anything. Okay. Now, I said there are so many different types of machine learning, and we have already looked into a lot of it. Okay. Uh, this is how it can be roughly understood. So classical machine learning, where data is pre-categorized or numerical. This is what we have been working, right? With supervised learning, okay, where we have categorized data. That was all supervised learning. In supervised learning, what we have classification, regression. We have seen this classification, okay? Our car sales data, which was classification model. And then regression, we have seen regression, our housing data, which was the regression, okay? Where we were dealing with prices and stuff and so on and so forth. And then we can deal with the regression. Okay. We haven't yet looked into unsupervised learning, which is clustering, association, dimension reduction. We might not cover everything. Okay. But when we go into deep learning area, then you will encounter a lot of unsupervised areas. Okay. Um, Now, how do you understand it? We already understood it. Classification can be binary, can be multi-class, regression, predict a number, unsupervised, clustering, transfer. What do you do? Reuse, basically reuse existing learnings and then discover new thing, something like that. You transform one model to another model. Reinforcement, basically you keep on learning. So you learn, you fail, you learn from your failure, and then basically learn again. So the idea is, for example, if there is a game of chess and for one particular board set, if you understand what is a board set, basically when all your pieces are arranged in a certain combination. And if you make any sort of move, what would be the best movement for that particular combination? Okay. And so on and so forth. Okay. Different types of data. Obviously, we have different types of data, and all of these different data can be actually analyzed in different ways. We also looked at data science workflow. Okay. We have covered static data and so on and so forth. Python, we have covered pandas. We have looked quite deep into matplotlib. We have looked into machine learning model, and we have also solved some problems. Okay. Evaluation, what defines success? We know already quantifiable metrics we need to see. And this is what we have deciphered when we were learning scikit-learn for quite some time now, that how we define success. Okay. What is modeling? Modeling is basically splitting data. Okay. This is how we have done. We have also seen this, how we split data. Okay. If you remember, this is all coming from the first class slide. You had a lot of questions in the first class, and we have covered a lot of things that I just mentioned in the first class. Okay. Structured data, what we can use. Obviously, we can use this cat boost and XGBoost, which we haven't not covered. We have only covered random forest, which is basically easy. In general, you can experiment with these models as well. It is present in scikit-learn. Okay. Unstructured data, we will be looking into deep learning. We might not look into transfer learning, but transfer learning is not really very complex. It is more sort of how it says. When you learn one model, you can apply the same learning into another model, and you can basically use that. You just need to understand the core concept of it, and then you would be able to use it. Okay. How do you tune a model? KNN, random forest. So there are, for every algorithm, there are different sort of ways where like you can tune model. Okay. We have also looked into it when we were looking at our scikit-learn and how we were doing it. Guys, with scikit-learn, we just covered it yesterday. With scikit-learn, how are we tuning our model? Answer me. Hyperparameter tuning, I know that. But how? How are we doing? That's good. Go more deep. That's basically randomized search CV, grid search CV is extremely automated with. Go much deeper. We have done this at least two classes. Estimator is one. Yes. What other ways? What are other things that we look at? What are other ways that we try to optimize it? Cross validation, correct? Okay. What is cross validation? What is cross validation, guys? I feel like most of you are just attending the class to say yes, sir, yes, sir, yes, sir, yes, sir. No, sir, no, sir, no, sir, no, sir. Audio not clear, sir. But when I ask questions, no one answers. Accuracy, precision, validating the model on different samples of data. Correct, Niharika. Very good. Right, Siva. Okay. The rest of the people are just here for yes, sir. Okay. Machine learning models have hyperparameters. Definitely, we can tune it, right? We have seen all of these. I think from the first class, we have covered so much. We have seen a lot of these things. Okay. Accuracy can fluctuate, but should not dramatically. I have talked about it, though you have not exactly seen it. Underfitting is low accuracy, overfitting is high accuracy, but I've talked about it. For example, you can't have more than 100% of accuracy or something like that. Okay. It becomes overfitted. That means that you definitely need to have error rate. If there is no error rate, which means that your testing data is wrong. Okay. And underfitting is basically extremely low accuracy. People who are responding extremely late are suffering from dyslexia also. Why are you responding so late, man? Cross validation, it's not even a one line answer that you have studied it yesterday. Probably it takes time to search on Google. That's why. Okay. Data leakage, problems with comparison. There can be data leakage, there can be data mismatch, underfitting, and overfitting. So if there is overfitting, that means we need to collect more data. If there is underfitting, then we basically try advanced model, we try to adjust hyperparameters, we try to reduce amount of features, we try to train longer, and so on and so forth. Okay. This was from our first class, and we have covered a lot of it in from the first class. Okay. Then what we did, we have gone through Python, right? And let me open up our Python stuff for refresher. Okay. You can tell your friends what topic we are doing. Always late. For overfitting, it is to collect more data. That means you are getting more accuracy, which means that there can be two reasons. Either you have extremely less number of data, or you have not done the split properly. You are trying to test on the same data that you trained on, because there is no error coming. Okay. My screen is visible to guys, to everyone. Guys, screen is visible. Okay. So we covered Python then, because I said Python is the very fundamental that you need to understand before even diving into machine learning. Because as you see, up until now, we have been using Python code, obviously, to play around with Jupyter and so on and so forth, a lot of these things, right? So what are we doing here? Obviously, we are basically triggering uh, the first class. We started with hello. We use print command to basically print something. We take input command to actually get input from it. There were several data types we talked in Python: int, float, bool, string, list, tuple, set, dict, right? Now I want you guys to tell me which are the immutable data types. Which are the immutable data types in here? String, tuple, okay. Both string and tuple is right. Cool. At least you guys remember Python now. Everyone was sleeping in my scikit-learn class, right? Or watching Kalki. Okay. Print. Okay. Print 2 plus 4. So we looked into these operators, plus, divide, and so on and so forth, right? We looked into several operators. There were few tricky ones like modulo, which gives remainder, double star, which is basically power off, right? And double division, which basically gives rounded. Okay, it's more sort of a it gives rounded off value. Okay. Okay. Int, float, tuple, string, complex. Cool. Okay. Then we had several inbuilt method that we could use. Round, round for basically getting round of n digits, abs for getting absolute value, bin for basically getting binary version of the value, and 0b was the annotation actually that we were using for annotating stuff. Okay. Then we had several operators that we looked into anyways. Okay. And this division, we talked about how is this division happening. This is exactly following BODMAS rule. Okay. And people who don't know BODMAS rule, for them, all I can say is RIP. This is what I can say. People who don't know BODMAS. Okay. Cool. Then we looked into several sort of constants. So there was this is how we define constant. This is how we define the normal variables. And then we looked into some naming conventions. You basically use underscore. And then for constants, you use all capitals. Okay. We looked into expression statements. Anything which follows some sort of computation is called expression. This is what I talked about. Then we talked about augmented assignment operator, which is this, right? This is called augmented assigned operator. We did a lot of things with the string. This was single line string. This was multi-line and string, and this is how it can be concatenated. Then we learned about typecasting. Okay, this is how we can typecast something. We also looked into escape sequence. We can use backslash to actually escape, uh, inverted commas, and so on and so forth, right? Uh, we also looked into formatted string. This is another way how we can concatenate strings. Uh, and the Python 3 way is actually to use F. And if you remember in our scikit-learn program, we have been using this format a lot. Okay. We talked about string indexes and how we can manipulate some error and so on and so forth. This is really essential when you are actually trying to clean up your data or trying to test up with some small data set, and we have used it in our scikit-learn. We talked about immutability. Okay. Strings in Python are immutable. This is what I said. Okay. Built-in function methods. We basically explored a lot of string inbuilt function methods, upper, capitalize, lower, find, so on and so forth. We talked about Boolean, true, false. We talked about type conversion. Okay. We talked about password checker. This was the problem that we actually made and tried to use all our knowledge, right? And then we also talked about list and how we can actually write list in Python. List is not really homogeneous. We can have any type of element within the list. This is what we saw. Um, because it comes with a lot of flexibility. That is why we also need to put in more effort to clean our data and so on and so forth. We also talked about metrics, and this is sort of thing that we have also looked into. If you know about confusion metrics that we have been talking about, this is the format that we looked into. It is a two-dimensional array, right? We also looked into a lot of list methods like append, insert, extend, pop, remove, clear, index, so on and so forth. Okay. Then we talked about none, which is basically non-existence. We also talked about dictionary. Dictionaries are what? Okay. We talked that keys can only be immutable values that cannot change. Okay. While while values are mutable. Okay. And keys should be unhashable. Okay. Cool. Then we looked a lot of examples for dictionary and how we can actually loop through it or get data out of it. User.keys, user.values, user.items, and so on and so forth. We looked into how we can pop item, how we can update. We also looked into tuple and how a tuple different from lists. We looked into the properties of tuple. List, the main core difference with list that tuple is immutable actually. Okay, this is what we looked into. Um, and also tuple is very less flexible, but they are much more performant. We also looked into sets, and sets have what? Sets have basically this type of bracket. This is what we looked into. And this was our Python data structures. Now tell me this, do you guys have any questions up until this first sort of class, up until our Python data structure coverage? So everyone is clear about all of these Python concepts, right? If anyone has any doubts in all of these data structures that we looked into, you guys can ask me now. I assume no one has. So shall we move forward? Let's move forward to our core. Okay. In the core topic, we learned about conditionals, how we use if, else, and this is where we started applying a lot of logic, right? If something is true, then what happens? If something is false, then what happens? We looked into what is a truthy value and what is a falsy value. Okay. And we actually explored several examples of truthy and falsy values. Okay. Uh, and then we also created some sort of logical program. Then we looked into ternary operations and how we can perform some sort of ternary operations and one-line operations in Python. And this was one of the way where basically you had this body in the beginning, and then you had if, then you had else, and then body of for else here. So this was like one-line way to actually execute if else. So Python sort of provides a lot of shorthands, and this is what it was doing. Then we looked into short circuiting. A quick question: what is short circuiting? Answer me this. What is short circuiting? Guys, what is short circuiting? It just, okay, I feel like only one person is sort of paying attention to the class. Exactly, it just evaluates the necessary logical operations. Okay, correct. That's what. For example, if both of these are true, right? In our operation, we don't even need to check for other condition, because if one is true, other is this whole statement becomes true. Okay. And in similar scenario, if the first one is false, we don't even need to check the second one, because this all become false by default. Okay, this is what short circuiting is, where like the Python program actually short circuits halfway because it already understands that what will be the logical answer to it. Okay. These were different sort of logical operators that we looked into: greater than, double equals, so on and so forth. And we looked into different sort of operations. Okay. Um, I asked this. Now we have already answered this. Tell me this. Why A is greater than B, okay, is what would be the output here? Okay, at least you know. ASCII value. Cool. Cool. Okay, false. Yeah, it's because it's an ASCII value. That's what it is comparing. Cool. Then we looked into some of the operation. Then we did is versus equals and so on and so forth. Okay. Um, Basically, we have one is one. This is what we can do. Where we understood that is this basically is keyword does very strict checking, and double equals do not do that sort of strict checking. For example, empty array is empty array. This is two completely different lists. While in here, empty array double equals empty array is true. Okay, this is because it also compares positions. Okay, then we looked into loops. Uh, for in loops is the most common type of loop that we have been exploring, and this is also the most common type of loop that is used. This is used also for dictionary and so on and so forth. Basically, we call iterables. And there are different type of iterables, tuples, dictionary, and so on and so forth. We looked into it. Then we also learned about counters and how we can loop through it. We looked into range, and this is something that we have already used in our scikit-learn, right? We have also looked into this enumerate and so on and so forth. We looked into what is enumerate. Okay, what is enumerate? Guys, what is enumerate? Right, it gives value with index. Correct. Then we looked into while loop. Okay, and there are some sort of cases where we do use while loop. In most cases, you don't really need it nowadays, but in some cases, you might need while loop. Okay. Then we looked into some different sort of scenarios. For example, this is one case where we saw how we can use while loop, okay, while true, and then we wait for some input and so on and so forth. Um, then we looked into break, continue, pass. Pass is something that you never really use. It is more like a placeholder. We looked into continue, where like it just escapes the next statement and so on and so forth. Okay. 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 We looked into some other problems like find duplicate and so on and so forth. Okay. So we looked into several sort of those sort of topics. We also tried to understand functions, and this we have already used again. We understood about some principles like dry, do not repeat yourself. This is exactly why we need this. Okay. We looked into parameters and so on and so forth. Uh, we Yeah, basically positional arguments and how do we call it with default parameters and so on and so forth. This is what we looked into. Okay. Then we understood about like how we use return statements. We also try to understand what are method functions and so on and so forth. Okay. We try to understand the doc string, which is more sort of a comments and sort of thing, and it gives us some understanding of metadata and so on and so forth. Okay, to understand your existing functions or whatever you wrote. Okay. Uh, we made some logical operations and some programs using whatever we understood. Then we also tried to take into account this args and quarks. This is not something that we have used up until now because mostly we have been programming within Jupyter, and hence why we didn't really needed it. But when you are doing something inside VS Code, you might need it. Okay. Where there were two rules, like I think I set a rule like this is how you need to set it: args, default parameters, and then quarks. So params, args, default parameters, and quarks. Name, args, default parameters, and quarks. This is what you need to do it. Okay. Quarks is more sort of a dictionary or something where like you pass in keyword and naming and so forth. Okay. Um, and args is just you are passing a list of arguments. We also understood about scope and how we cover scope. Okay. We also understood about global variables. Yes. Cool. And we looked into the this whole how some variable is non-local, and there is this new non-local sort of keyword in Python 3 and how we can use it. We actually saw the use of it. Right. Can someone explain me what is happening here? If you guys remember, tell me what is this non-local doing? I know it is non-local. Spelling is non-local. I want to know what it is doing. Okay, let's try. Let's try to basically run it and try to see. This is what 36. Okay. Why do we get this as non-local, outer as non-local? Why do we get outer as non-local? Okay, now let's try to remove it and see. You see, when you define this as non-local, okay, it basically exactly. I wanted to hear some concrete definition. Non-local refers to nearest outer variable. Correct. Okay. Then we also looked into filter function, how we can filter out list and so on and so forth. We looked into zip function. Okay. Um, Zip is basically useful at a lot of places. We looked into it, how we can zip both of these together. Okay. Then we looked into reduce and I explained reduce in detail. I also explained list comprehensions and how you can do list comprehensions as such. Okay. It sort of follows the same single line sort of syntax when we were doing this if else sort of thing. Okay. Where you have the main body in here and then you define your loop in here and then you have your secondary body here. Okay. So your loop, your condition, and then your body. Okay. These are the parts that you need a lot more practice on because this is something that is much more confusing. List comprehension, lambdas, and so on and so forth. Okay. We also looked into lambda functions. No, I won't share this. The reason I won't share this because this particular thing, I asked you guys to make notes yourself and practice it yourself. So I won't be sharing this. And there was a very concrete reason for me to do that is because I already had these notes. I didn't wanted to share it because I want you guys to make your own notes and self-practice it. And if you haven't done it already and you don't have your own notes, then maybe you didn't pay attention in the class when I was teaching. For the rest, Jupyter notebooks, I have already shared that. Okay. Cool. Lambda functions can basically take number of arguments and then we can perform like one line operations directly. Very straightforward, very useful, very fast. Hence why we use it. Okay. Then, okay, we didn't discuss about modules, but modules is more like you can just import. Okay. You can import from like, for example, Lambda or something like that. And then you can access functions from them. That is what this module says. I didn't really show this because we didn't really need it, but it's more like you can import these modules. And we have seen this a lot. It's just that we are not doing multi-file operations yet. Cool. Any questions up until now for this whole Python segment? For this whole Python segment, does anyone has any questions? Okay. Now you guys remember, do you guys remember Um, okay. You remember the installation process of Conda and basically all of these things. I shared this README file, I believe. Okay. Sir, we must give Lambda functions. I mean, depends on your use case. I don't know what are you asking, but if you have a use case where you are basically you want to create some sort of shorthand functions, you can definitely use lambdas. Okay. But do note lambdas come with a precaution that it is a bit confusing at times when especially when you are dealing with something complex logic. Ideally, I recommend to actually expand and not use Lambda. This is just my recommendation. But if you think that maybe it's understandable, it's not so confusing, you can definitely use Lambda. And in a lot of projects, you will be seeing that it is being used. Okay. Okay. You guys remember how we installed Jupyter and stuff? For anyone who don't remember, I think I shared this whole README file, okay, for installation. And if you remember, I asked you guys to install Miniconda. The reason I said to install Miniconda is Anaconda itself comes with 1500 plus packages pre-installed, which you technically don't need, and you can install things one by one. Once you install Miniconda for Windows, there was separate method. Okay, I have a Mac, so I can't show that. In Mac, it was very much straightforward. Okay, you just need to actually download the file and then install the package, and it works out of the box. Okay, and this is how you can install each of these. Oops, maybe. Okay. This is how you can just install stuffs. Okay. And this is if like you want to pre-configure it with some existing packages. So I have like configured it to have these installed by default: Pandas, NumPy, Matplotlib, scikit-learn. I could have added Jupyter as well. I just didn't add because I wanted to show you guys if you guys remember it. And then so on and so forth. And then I also wrote some basic sort of shortcuts here to use Jupyter. This was very basic, but I believe if you might have been practicing, you would have learned a lot by now. Okay, A to add cell above, B to add cell below, M to make it in a markdown mode, Y to basically undo something, Tab to actually trigger auto completion, double D to actually delete cell, and so on and so forth. Okay, you can also switch into Conda, switch out of Conda environment and so on and so forth using Conda ls. And I also gave this description, which I didn't really show, but the description lists that how you can actually share your Conda files. Okay, so now then, let's go into our Jupyter. Okay, we are doing a full recap today. Hence, I keep asking if you guys have any questions on any topic, you can ask me now. I'll answer it. Today's topic name is recap. I mean, I seriously doubt you guys. Whoever keeps on asking topic name, man, either you are trolling or you have literally zero IQ or you are not really interested in the class and someone has forced you to attend it. Is it like so? I mean, even okay, you are cool. You are late to the task class. I understand it. Okay, but even if you basically go through the class slowly, you will understand what we are studying. Also, I don't know why you guys have to come 1 hour late. I literally did a full recap of the things. Now, imagine if you had so many questions in the first class, you can't ask that. Try to try to be much more attentive on your classes, okay? Because after all these sessions are over, I'm not here. You can't ask me questions, okay? I'll explain. First of all, we didn't do any KNN. And to explain you in one line, because I won't go into deep algorithm, you can read it yourself, Sandeep. KNN is basically an algorithm where we try to find distance between each of the items, okay? And hence we call it K nearest neighbor. So the idea is we have some sort of mean sort of average value, okay? And the machine learning model tries to take out the distance between that from X point, which is your mean average, to Y point, okay? And sees if it falls in that mean average zone, okay? And henceforth, we call it KNN model, okay? So everything that falls into that mean average zone is predicted as true. It is a very common classic classification algorithm. Cool. We haven't done or used KNN algorithm yet within the scikit-learn. And to understand the algorithm itself and the code, you need to go and look for it. This is not something part of the course. And like I said, even yesterday and day before yesterday, if I start explaining each model in a lot more depth, it's going to take whole book, and even then we won't be able to complete it. Okay. For random forest, the concept is different. We basically use decision trees. Now, exactly this is where the problem comes because you don't understand what is decision trees. Okay. So the idea is that you use decision tree, which is more sort of something like a flow chart and so on and so forth. Okay. And each node sort of represents several true and false and so on and so forth, that where something will go. So it has like several nodes, and then you have yes, no, yes, no, yes, no, yes, no. And this model actually takes decision based on these decision trees. Okay. Now, random forest is ideally applied, okay, in both classification problem and also in regression problem. Okay. To be honest, I would highly suggest you guys actually go and learn about decision trees because it is very important and it is very popular and used in a lot of things. Okay. Especially in machine learning, it is used a lot. Okay. The whole idea is with the decision trees, you try to use select the best attribute. Okay. And that is where random forest come into picture. So you can read about this whole algorithm and you will understand. The most common problem with the decision tree is overfitting. Cool. Okay. Chandu Kiran, we want to open Jupyter Lab or Jupyter Notebook. See, ideally, I have shown you how you initialize the Jupyter Notebook locally in your system. Because if you work for any company, they won't use Jupyter Lab. Okay. They will probably use some sort of local setup eventually. It's just much easier for you and beneficial for you to get familiar with your local setups fast. I am also showing it on Jupyter, but at some point, you will have to move away from Jupyter Notebook as well, and you need to do it on your IDE. Okay, it can be Visual Code or it can be PyCharm. This is why I asked you guys to install PyCharm, because that is a tool which comes with inbuilt debugger and so on and so forth. You can use that PyCharm and then you can try to run the same things that we have been running on Jupyter Notebook, and you will get basically same type of outputs. Okay. It's just that when you run it within an IDE and you actually save your model and so on and so forth in using joblib or pickle, you can reuse it from your Python IDE inside your program directly. Okay. Cool. So let's look into it. Hmm. We've done a lot of pandas already, right? And we'll be covering pandas along the way. And if you guys have any doubts in pandas, you can tell me, because it's very straightforward. And the most important thing that you need to know in pandas is more sort of data frames, and then it's all functions out of it. Okay. Now, if you remember, we talked about NumPy, and NumPy. Why are we using NumPy? First of all, answer me, someone. Okay. Why can't we use inbuilt methods for numerical operations? Is it not full screen yet? Is it not visible? Is it visible now, guys? NumPy is fast. Why is it fast? Why is it fast? Why is it fast? Why? Why? Question is why. I am asking why NumPy is fast. You guys are saying 200 times used for numerical. Okay. Because it performs by binding and it is written in C, thus more performant. Cool, but you, okay. Cool, but you have actually wrote a very wrong sentence structure. But you are right. It is it Python has C bindings, okay, and it is NumPy is completely written in C, hence it is really fast, okay, which is very essential for the kind of data set that we work on in machine learning. Okay. And then obviously it provides a lot of supporting functions as well, which is not bad. NumPy array always starts with this NP array and so on and so forth. Okay, we looked into this anatomy where like we understood, okay, how we visualize NumPy. Okay, we talk about shape, if you remember, okay, 2, 3, 3, and so on and so forth. 2, 3, 3 here is like what? So you can see this actually. 2, 3, 3 in here. 2 means 2 axis, 3 means 3 rows, and 3 means 3 columns. Okay. Yes, you can also call it dimension, axis, however you want to refer. Cool. Then we looked into how we can get shapes, how we can get dimensions, how we can get data type, how we can get size. It was all very straightforward. Then we also converted NumPy directly into data frame using pandas. Okay, we tried to fill in these empty positions with ones. And now, if you remember our scikit-learn, you can somewhat get an idea that your columns are filled with ones. Right? Then we basically generated a lot of random arrays. We then also generated random arrays with seed, so on and so forth. We did a lot of these randomization operations. We performed all of these modulus things that we have already done. And then we also did this using NumPy directly, using NumPy's functions like square, add, exponential, log, and so on and so forth. We generated a huge, massive array using NumPy. When did they say our internship should be completed? Seriously? So elegant, so beautiful, just looking like a wow. That's what I want to say after reading this question. Okay, cool. Then we also timed summation of this massive array. Okay, that how many loops it took and so on and so forth. And we saw that it performed super fast. Performed super fast like summation. Let's try to run this again. And it's doing summation of this whole massive array. Okay, basically here. And let me start this one also. And let's see. 10,000 years later. Maybe this notebook crashed or something. Because I think so. This is the old notebook and it's not working as we expected to work. Okay, where were we? Where were we? Where were we? Okay, we were here. We generated this massive array. Okay, we generated this massive array, and then we wanted to take out this sum. And yeah, see, this was super fast. While this, if we take it out, it will take a lot of time. Yeah, comparatively, it took much more time, right? So this is where the power of NumPy comes in. Um, we can do a lot of things with NumPy, and I have only scratched surface. Like I didn't go really a lot more deep into it. We can do a lot of things. It has applications even outside machine learning. Okay. Mean, max, min, standard deviation. This is something that you might use if you are doing some sort of statistical calculation. I don't know how many of you are actually interested in statistics, but it has a very huge scope in terms of data science itself. Okay. Um, Variance. And then we also did some sort of plotting directly from using matplotlib. Okay, we did some plotting using matplotlib. We drew some histogram, uh, we reshaped and so on and so forth. Again, try to get argmin, argmax, did a simple plot. Okay, and then we talked about two sort of interfaces that are there in matplotlib. What are those two interfaces? What are those two interfaces? Half of you guys are sleeping or what? Who is this Suresh in this chat? I want answer from Suresh. How many people are 243? I remember in my first class there were 1500 people and now there are 243 people. So funny, man. Suresh, let me DM Suresh. Hello, are you there? Okay, let me check more people. Okay. What about Tulsi? Is Tulsi alive or not? Let's see. Hello, are you there? Okay, no. All half of the chat is dead. Okay, cool. Let's see. Okay, cool. Tulasi, at least you are alive. Cool. Tulasi is alive. Cool. Let's see. Hello, are you there? If you guys are there, then also start answering when I ask questions. So Ganla Brundavani is not there. Ramakrishna, what do you think? What is the purpose of these classes? I mean, what do you think? What is the purpose of this class? I mean, I already saw your question, so you can just answer over like there's no point in deleting it. The main goal of this class is we want to grow up and be a good cricket player. Prabhas, are you there, Prabhas? I see some Prabhas here. Prabhas? So, Prabhas, very, very sort of pathetic situation that there are 250 people in the chat, and I believe 70% of them are sleeping. That is why no wonder at the end of class, most of the people are saying, Sir, what is the topic, sir? What is the topic, sir? Just coming for attendance, no other use. I'll tell you guys, let me spare 5 minutes. Yeah, only attendance is important, knowledge is not. Let me tell you guys, I don't know whoever is listening, whoever is attentive enough. Uh, you guys know that chat GPT is here. You guys know machine learning is here. You guys know how the market is. I don't know if you guys know or not. I myself do hirings. Okay. I hire for my company, and I can tell you for sure nowadays in the market, people don't really need junior engineers. Okay. People don't really need junior engineers. The reason is no one wants to teach anyone. Everyone now expects that you know it and you don't copy things from ChatGPT. That is the expectation. The idea is that you use ChatGPT or Stack Overflow as a tool to boost your speed. Okay. No one expects you to actually teach you slowly, take their time, and so on and so forth. I think in each of your classes, you guys are 80, 90, 100 people or so on. The reason is obvious. You guys thought that computer science is the booming side and it gives high salary, and you have seen read stories for 99% of the people. This is the true thing. Some of the boys actually got interested in it because they were gaming a lot. Okay. Girls got interested into it because they felt, okay, it's not on-field work, and that is why it's just easier compared to something like mechanical or civil. Uh, a lot of people actually get into it because of that, and there are few who are genuinely interested in computer science as a subject because they really like mathematics and stuff. Okay. No matter what the reason you had to actually enter into it, no matter what the reason you had, you eventually want to get a job, right? And if you want to get a job, it is very hard. It is very hard nowadays. And hence, these sessions that you are getting, whatever knowledge that you are getting, whatever time you are getting, this is very important. Because once you have a gap, do remember this, once you have a gap after your university or college ends, no one is going to hire you as a software engineer. It becomes super hard. Super hard. Trust me on this. That is if you really want to work as a software engineer, and I believe you want to, that is why you are attending this session. If you don't, it's completely fine. Henceforth, try to make use of this session that you have. I'm not saying I'm the best teacher. I'm also not saying that you will learn everything in this class. There are so many things that is obviously that will be left in this class. But what I am saying is try to understand the market. All you are doing is to get a job. Be job ready. So be prepared for it. Bring that seriousness. You will understand it when you don't have any money. You are looking for a job and you're also not even getting a job. Your college is over and you still have to survive from your parents' money. It feels super bad. I hope you guys understand this. Uh, to be honest, I don't really care how many of you guys are serious into it or how many of you guys are forced into this class. But all I am saying is I am in the market. I know how it works. Okay. Utilize this. If you don't even want to learn from me, don't learn from me. I'm not saying learn from me. I'm saying you know the topic. Everything is available also in the internet. If you can do it yourself. The only reason why you need a teacher like me sitting in here is to give you some outline. This is how you need to go. This is your path. That's the only thing that I'll do. Okay. For people who are not paying attention, it's completely fine. I'm not saying. What I'm saying is you will just really face huge problems when you apply for jobs. To be honest, no people, at least in online classes, will care if you actually attend or not attend, or you pay attention or not pay attention. Because for me, there is no loss. All I have to do is fulfill my target. I complete this class, done. Why I keep asking for your, if it is visible, if you are able to hear me clearly, if you are paying attention, I ask question. The whole reason is because I want you guys to actually learn and pay attention, be awake. If you can get something out of it, I hope you do. If you don't, you will literally regret a lot. Trust me, not now, but you will remember me after you complete your graduation. Okay. So to continue, let's try to continue our recap. Okay. This is very useful, guys. We won't repeat this recap again. So try to take, if you have any questions, ask me. Okay. So we have two types of interface. Someone already answered object-oriented interface and the default interface. Okay. When we use subplots, we use object-oriented interface. Why do we have object-oriented interface? Answer me this fast. Why do we need object-oriented interface? because of flexibility of plots and to make customizations 100%. Okay. Cool. We did a lot of these things, link space and so on and so forth. Okay. Then we talked about subplots, we talked about scatter graph. So we saw a lot of these things, okay? Um, and then we said title, we created some bar graphs. If you remember, this is the sort of flexibility that we were talking about. We can actually create multiple access, multiple graphs in the same plot and like literally visualize things as we need, customize it as per our needs. Okay. If you remember, on Pandas, we could create series. What is series in Pandas? Quickly answer me. What is series? One-dimensional data. Correct. It is one-dimensional data. Come sum, cumulative sum. Cool. Um, this basically takes some cumulative sum. Tell me what is cumulative sum. Tell me what is cumulative sum. Sequential adding. So you basically add uh, first value to second value, second to third, third to fourth, fourth to fifth, and so on. So correct. Okay. Finally, we started experimenting with proper data set. We had a small data set of car sales. It had only 9 items and so on and so forth. And we started polishing this data. We did some regex and something like that to actually polish up and this price data, get numbers out of it. Okay. This is how we polished up our data, created a more polished data frame, and then we started plotting graphs on it, that how our total sales worked and so on and so forth. What was this part of? Okay, why are we doing this, all these graphing and so on and so forth? Why do we need this? What are we doing as of now? What are we doing right now? What is all this? Why are we plotting this? Tell me, guys, what is all this? Why are we plotting these? There is exact word for it. Okay, correct. Visualizing the data is more effective way for data analysis. The whole reason that we are doing this is for data analysis. That is the main use case. Okay. Henceforth, we try to create graphs and so on and so forth, a lot of visual representation, so as to do data analysis. Okay. We try to generate graphs and stuff to do data analysis. Cool. We had another data set, heart disease, and we started plotting things and so on and so forth. Okay. A lot of these experimentations that we did some basically, we also talked about how we can set legend, how we can set colors, and make more effective. We also created mean line coming from here. Okay. Someone was asking me what is KNN. Okay. So imagine this. This is this your mean. Okay. From this mean, you are actually trying to look for K nearest neighbor. Okay. So we did a lot of drawing and stuff in here, mostly plotting. We could change styles we saw based on whatever color scheme we need. We can define our custom colors as well. And we saw a lot of these things in here. Okay. Then finally, this was our more concrete class where we actually started doing more things with pandas and data frames. Okay. We tried to understand data frame series and so on and so forth. Uh, Basically manipulated it, try to get index, try to get info. Okay, why do we need all these informations, index and so forth? Again, for why do we need all these informations? For data analysis, correct. Exactly. We need all these information for data analysis. Right. If we know data types, we know if it is object, if it is an integer, or so on and so forth, we can do proper data analysis on it, and we can manipulate this data much more easily. Right. We saw several functions like head, tail, so on and so forth. Okay. Location, eye location. This is all to actually get a very small segment of data and maybe try to get some understanding of what this data does, what it looks like, and so on and so forth. We also did some bare minimum plotting, and this tells us, okay, how the spread is like. Okay. Are we having variable data or not? For example, assume we draw this graph, odometer, and if there is just a straight line, is that a good data set? If there is just a straight line at 125,000, is that a good data set? Why not? Why not? Correct. Same value. Yes, Sri, just type the question. Exactly. It's same value, and there has to be variability in this graph. There has to be variability in this graph. Okay. Why do we need variability? Why do we need variability? Variability in here, in easy terms, it means the data should be like this. Like it shouldn't be all, like all data points shouldn't be of same value. It should be of different values. Okay. And I'll tell you why do we need variability? The main reason is, yes, to predict the unseen data properly, and also to have some sort of error rate. Without any error rate and without having diverse set of your data, you can't make proper predictions. Okay. Then we again polished up our data. We also looked into missing data and how we can fill in missing data. Okay. What happens if we have missing data? What does happen when we have a missing data somewhere? Correct predictions are not made. Correct. Before that, you won't be even able to make predictions, okay? Because of the absence of data. Because of the absence of data, you won't be even able to make predictions because it is just like missing data. You need to have data. And that is why in scikit-learn class, if you remember, we were getting a lot of errors when we had missing data. So there were two options that we did. Either fill in those data points or omit that. Okay. I'll recap that whole circuit because that is the biggest module that we have. I'll recap that whole stuff on Monday. Okay. Then we fill the non-existent data, so on and so forth, series, and a lot of stuffs that we did. We did some shuffling. We tried to add new columns with new data sets, with new data points, and a lot of these things, okay? Sometimes, when you are doing data gathering and data collection, it might happen that you might be the person who is doing this data collection. So you might need these things. Okay. Finally, this is the thing that we'll cover on Monday. We'll do a full recap of scikit-learn from start to finish. Okay. Obviously, we'll do speed run, but I'll take in a lot of questions. If you guys have any doubts, come prepared. Okay. You can ask me questions. There are two types of question, obviously, that I won't answer. One is if you try to ask me like, okay, please go in depth and explain me this particular algorithm regression, or please explain me this maths of this. That's not something that I can cover in the given time frame and the class that we have, because of the shortage of time also, and also it is not part of our syllabus anyways. Okay. But what I can do is I can give you a very high level overview of all of these things. Why are we doing certain things? Why we need it? Maybe I can give you a high level definition of regression. I can give you a high level definition of all of those things, so that you have a very fair understanding of why and what we are doing. Ask me questions on this. Okay. We need to get more familiar with this methodology. That is why we kept on repeating the same step throughout the scikit-learn process. Okay, we repeated the same step, and these are the same step that we repeated again and again. Get the data ready, pick a model, fit the model, evaluate the model, improve through experimentation, save and reload. We repeated this so many times. And I'll recap this again. And I hope after that, you will be very much familiar with scikit-learn, and you should be able to take your learnings from there. Okay. Now, guys, any questions up until the point of scikit-learn? By the way, I believe you might have not got the scikit-learn notebook. It will be shared shortly, because today only I shared it with the Blackbucks team. Okay, so sorry for the delay. I'll wait for 5 minutes for any questions. If you have, you can ask me. Sure, I can recap Pandas. Give me 1 minute. Cool. Is there anything specific that you want to ask in Pandas? Okay. So if you remember, in Pandas, basically we are using Pandas to structure our data. We get Excel or whatever, but we can't manipulate that Excel directly. The whole reason we have this tool is so that we can easily manipulate that data. Okay. What Pandas does is it creates something called as data frame. And this data frame is very similar to a table, a very visualized sort of table that we can actually manipulate and work with. Okay. Now, there are two sort of layers into it. One is definitely series. Vivo, if you have questions, just ask me. Okay. Ask me on chat. Type it. I'll answer you. Okay. So one is series. Series is mostly single dimensional. Okay. Which syntax, Lalsa? Just write it down. What syntax you're not able to understand? Or you want me to increase the size? Okay. So I'm explaining the syntax anyways. Oh, sorry. I'm sorry. I didn't even share the screen. I'm sorry. I'm sorry, guys. Okay. Now it should be visible. Hey, when screen is not visible and I'm explaining something, just tell me right off the bat. Okay. So guys, pandas, we use it to get some sort of tabular representation. We have series. Series is what? It's a single dimensional representation of an array. That is why you see 0, 1, 2, and that data 0, 1, 2 is more sort of an index in this data. That is what series is. Okay. In here, PD is just an alias. Okay. What is an alias? It is a synonym sort of nickname for pandas, or else you will have to type pandas.series every time. Okay. Just so that I don't have to write everything, I use PD as an alias. So we do PD.series. Cool. Then if we have a two-dimensional data set, okay, which is the case in most of the times, like your Excel sheets and so on and so forth, you can represent that via a data frame. And like I said, it gives you a good visual representation, which is what is happening here. Okay. We imported a CSV. It was an Excel CSV sort of file, which had these columns, these rows, and we can visually represent it here. Using pandas, we can just directly get a data frame. And why do we need a data frame? We need a data frame because then we can manipulate and get a lot of information about that particular data right out of the box because of the library itself. For example, we can get data types, and if we ask it to describe, you see that it describes everything very clearly, right? We can get index, we can get a lot of information like how many entries were there, what is the memory usage, and so on and so forth. Okay. Um, in that data frame, we have been given a lot of inbuilt functions, and mind it, pandas is built on top of NumPy, and hence why internally it uses NumPy to calculate mean, sum, and so on and so forth. Okay. But it gives and returns those values in a much more structured format for you guys to understand, and that is why we need it. If you see here, this is very structured and you actually understand what you are getting out of it. Same here, it is very structured and you understand what you are getting out of it. Okay. If you query head, then you get first 5. If you query tail, then you get last 5. If you pass in an argument like give me last 3, then you can pass 3 or any number. Okay, it will give you that sort of number. If you type it tail from reverse, if you type head, it will give it from forward. Okay, lock is basically refers to index. ILOC refers to position. Okay, index as in this is the index 113, and position is these value positions, which is like our 0, 1, 2. Okay. In pandas, in context of pandas, index can be redundant. To be honest, this is just how it is written. Position is technically how we refer index traditionally in an array. Okay. Then you have, again, we manipulated this data frame. We look at slicing, same sort of thing that we did in Python. Cool. This is all given in what? Pandas. Cross tab, we can actually make double sort of comparison between two sort of columns Why do we do this? To actually get more detailed information. For example, how many BMWs do we have for one car, for 3 doors, or 4 doors, or 5 doors, and so on and so forth. Okay. Then we can have group by, and we can group by with certain structure and take a mean out of it. That's the basic understanding of pandas. And on top of it, then we can actually polish this, calculate mean, and so on and so forth, and then fill in missing data. Okay, this is what we are doing here. We have a lot of nan values, okay, and then we fill in missing data, okay, with some sort of random value. This is what we are doing. So we can also omit that those data points which have missing values, like drop any. Any other doubt with pandas? Empty. So it's not complicated. Pandas is very straightforward. It has out of the box syntax. Uh, Obviously, you will have to go more through the documentation to understand it much better. Okay. But I think so on the base level, we have covered a lot of pandas, especially in scikit-learn. Anyways, I'll take a recap on Monday. But when we did this recap, when we did scikit-learn, we actually explored pandas a lot more. And you see, it comes in handy a lot when you are actually doing some modeling. Okay, any other doubts to anyone? After recap, we have to do deep learning. I'm just not. So they asked me to take a recap on Monday and Tuesday, but I don't want to stop in between of starting a topic. So once I start deep learning, I don't want to stop for recaps. Hence why I started recap today and I'll finish it on Monday. And then deep learning is our last module that we need to cover. So we'll cover deep learning. Okay, if no one has any questions, I'll drop. If you have any questions, just ask me. Cool, guys. I'm dropping.